everyone. In this lecture we'll be discussing how to solve how to find the continuous time Fourier series representation of certain given signals, and this is a continuation of the lecture. We have already started with this problem discussion, and in the second question we have considered how to find the Fourier series representation of this given square wave. We have evaluated the coefficients a0 and an value were 0 because the given function is an odd function, and bn expression we have obtained, which is 4a by n pi for only for odd values of n, and bn coefficient is 0 for even values of n. And we have to, in the question we were asked to plot the line spectrum, and we know line spectrum means it shows the amplitude of the different harmonic components, that is Cn. Line spectrum is a plot between Cn, the amplitude of the different harmonics, versus n. Okay, and Cn equation is root of an square plus bn square, and in this question an value is 0, coefficient an is 0, therefore Cn is equal to simply modulus of bn. And we have evaluated bn equation, and bn is having value only for odd n value 135, and it is 4a by n pi. Therefore when n is 1, bn is 4a by pi. When n 3, it is 4a by 3 pi. For n 5, 4a by 5 pi, and so on, and that is shown here. Here it is not v, it is capital A, 4a by pi when n is 1. For n2 it is 0, n3 4a by 3 pi, and so on. So this is how we have to plot the line spectrum. Now moving to the next question. The question is to find the trigonometric Fourier series for the triangular waveform shown in figure, and also we are asked to plot the line spectrum. And again in this question also you are given the waveform or the graphical representation of the signal x of t. The mathematical expression for this signal x of t is not given, so the first step is we have to find the expression for x of t. Only then we can evaluate the coefficients a0, an and bn. And again the different segments, if we observe, those are straight lines, therefore we can make use of the equation of straight line for evaluating the expression of x of t. And when we observe this waveform, we can identify that the fundamental time period of this given signal x of t, it is 2, because the given signal when we observe 0 to 1 it is decreasing, again from 1 to 2 it is increasing, and again the same waveform is pattern is repeating from 2 to 2 onwards. Okay, therefore the fundamental time period is 2. And also when we observe in this time period, we have to consider two different ranges, because from 0 to 1 it is one straight line which is having a negative slope, and from 1 to 2 it is another straight line with a positive slope. Negative slope means magnitude is decreasing, and positive slope for this line from the t equal to 1 to t equal to 2, magnitude is increasing. Okay, so you have to we know the equation for straight line. It is y minus y1 divided by y2 minus y1 equal to x minus x1 divided by x2 minus x1. Okay, in this case the x coordinate, I have already explained this in the first question, how to find the equation of straight line. So when we consider this signal x of t, on the x-axis we are given the time scale t, and so in the place of x we have to take t, small t, and in the place of y what we are having is x of t, our signal. Okay, so y, in the place of y you have to take x. Okay, so first we will evaluate the equation of the line for the region 0 to 1, t value varying from 0 to 1. Okay, so this origin is our first coordinate. The coordinates of the origin are 0, 0, and the second point is this, that is at t equal to 1. At this point x of t value is 0, therefore coordinate of this point is 1, 0. Okay, so the two end points of the straight line is 0, 0 and 1, 0. Now you have to substitute in the equation of straight line, and what you have to be careful is how you are taking the variables. I mean saying that once again, here x-axis is t, therefore x you have to take as t, and y-axis is x of t, so you take it as x. So when you substitute in the equation of straight line, you will get the expression for x of t for the time duration 0 to 1. Okay. Again, for the next time duration, that is for t equal to 1 to t equal to 2, it is another straight line, and at the coordinates at t equal to 1 is again 1 comma 0, and the coordinates at t equal to 2 is, it is 2 comma 1. 2 comma 1. Okay, now again substitute these two end points, that is x1 y1 and x2 y2 in the equation of straight line, and you will get the expression of x of t for the time duration 1 to 2. Okay, so they have evaluated, and the expression obtained is x of t is equal to 1 minus t for 0 less than t less than 1, and it is t minus 1 for the time duration 1 to 2. Now also, when we observe this waveform, we can clearly see the wave is an even function. Therefore, the symmetry condition requires that Bn equal to 0. That is, when the given signal is in an even function, the coefficient Bn is 0. Therefore, we just need to evaluate only A0 and An. Now, the equation is slightly different. That is, when we are making use of symmetry condition and evaluating the coefficient, the equation for A0 is 2 by t integral 0 to t by 2 x of t dt, and t fundamental time period t is 2 in this question, and also omega 0 value is there. For omega 0 is 2 pi by t, and it is pi. Okay, and t by 2 is 1. Therefore 2 by t is 2, integral 0 to t by 2 is 1 into x of t, that is in the range 0 to 1, x of t expression is 1 minus t dt. Integrating, and after substituting the upper and lower limit, we get A0 as 1 by 2. Next is evaluation of An. Equation for An is, when we consider, this is the equation when we consider the symmetry condition, and it is 4 by t integral 0 to t by 2 x of t cos n omega 0 t dt. 4 by 2 integral 0 to 1 x of t is 1 minus t into cos n omega 0 is pi cos n pi t dt. Now this is of the form of this integration is in integral of product of two function. So it is integral of product of two function is first function into integral of the second minus integral of derivative of first into integral of second. Okay, so they have directly expressed written the integration final answer here. This is 1 minus t first function into integral of cos n pi t is sin n pi t by n pi. First term is over. We just need to substitute the upper and lower limit, minus integral of derivative of first term. This is 1 minus t is first term, so its derivative is minus, and we know again integral of cos n pi t is sin n pi t by n pi. Okay, so when we again integrate sin n pi t, integral of sin n pi t is minus cos n pi t. Okay, so that minus and minus cancels, and this minus sign remains here. Okay, minus cos n pi t by n square pi square within the limit 0 to 1. Now when we apply limit, consider for the first case, this portion, when n t value is 1 minus 1 0, it becomes 0, that is for the upper limit, and when t is 0, lower limit 0, also it is the sine function sin n sin 0 0. So this first term evaluates to 0, only the second term is remaining, and it is 2 divided minus 2 by n square pi square into, when we put the upper limit, it becomes cos n pi minus cos 0, and when that minus sign is taken inside, we can write it as 2 by n square pi square into 1 minus cos n pi. Okay, and we know cos n pi value, it depends on whether n is even or odd, and when n is even, it is plus 1, and when n is odd, it is minus 1. So when n is even, cos n pi is 1 minus 1, an value becomes 0. When n is odd, this is cos n pi is minus 1, so 1 minus minus 1, it becomes 2 into 2 4 by n square pi square. So an value is 4 by n square pi square only when n is odd. Okay. Now we have evaluated the coefficients. We just need to substitute in the equation of x of t, that is trigonometric Fourier series expansion a0 plus summation n equal to 1 to infinity an cos n omega 0 t, and it is a0 is 1 by 2 plus n value only for odd values of n. See, 4 by pi square cos pi t when n is 1, and 4 by 3 pi when n is 3. 3 pi the whole square cos 3 pi t when n is 3. Next term when n is 5, and so on. Okay. Now this term contains only odd harmonic cosine terms, and also now we need to plot the line spectrum. As we have seen in the previous question, line spectrum is the plot between Cn, coefficient Cn and n, and Cn is, we know it is root of an square plus bn square. In this question, bn coefficient is 0, therefore Cn is simply modulus of an, and we know in this case an is having value only for n odd, and the magnitude of an is, see, when n is 1 it is 4 by pi square, for n3 it is 4 by 3 pi the whole square, for n5 it is 4 by 5 pi the whole square, and so on. See, and C0 it is 1 by 2, which is equal to A0. Okay, so this is a line spectrum. Then next is trigonometric Fourier series for the waveform shown in figure, and we have to, again the next question, we have to plot the spectrum, line spectrum. And if you see this, consider this question, in this the Fourier series, for again what we are given is x of t is a the graphical representation of x of t is given, the mathematical equation is not given. Okay, so we have to write the equation for x of t first, and when we observe this waveform, this is again a periodic waveform, and the fundamental period is 2, that is capital T is equal to 2, and the signal in the time duration when we observe, that is from 0 to 2, the signal x of t is having value only for the time period 0 to 1, and from 1 to 2 its value is 0. Again, in the time duration 0 to 1, what is x of t? It is simply t. X of t value is simply t. By observing the waveform, we can directly write. Okay, therefore we can write x of t is equal to t for 0 to 1, and it is 0 in the time duration 1 to 2. Okay, time period t is equal to, capital T is equal to 2, and therefore the fundamental frequency omega 0 is 2 pi by t, that is equal to pi. Okay, now the given waveform is it is neither even or odd, therefore we have to evaluate all the three coefficients, and we know the equation for the coefficient a0 is 1 by t integral 0 to t x of t dt, and it is 1 by 2, and we know the waveform is for two different time periods, 0 to 1 and 1 to 2, so it is taken like that. 0 to 1 it is t dt plus 1 to 2 it is 0, and evaluate t square, t integral of t is t square by 2, substituting upper and lower limit, we get this answer. Next is for evaluation of coefficient an equation is 2 by t integral 0 to t x of t cos n omega 0 t dt, and x of t again it is having value only in the range 0 to 1, t into cos n pi t. So this is integral of product of two function, as we have seen earlier, first into integral of second minus integral of derivative of first into integral of second. So when we do the integration, we get these answers, and now when we put the upper and lower limit, the first term becomes 0 because here we have a term sin n pi t, and what is remaining is simply 1 by n pi the whole square into cos n pi minus 1, and we know cos n pi value is 1 when n is even, therefore coefficient an will be 0 for even values of n, and when n is odd, cos n pi is minus 1, therefore an value is minus 2 by n pi the whole square for odd values of n. Okay, remaining we will see in the next lecture.